solve it. Bravo! Those who are unable to solve it, you can visit it again and try your hands on it. Today, we are on solving exponential equations under the simultaneous equation. So we pick some examples and go through together. The first example we have here is x plus 6y equals 3. Then 2 exponents x plus y equals 1 over 4. And we are to solve this simultaneously. And you know what a simultaneous equation is? It involves two unknown variables. So, the first equation, we are going to label our equations. We take the first equation as our equation 1. Then the second as our equation 2. Good. Looking on the board, our equation 1 is already linear. So we are going to tackle the equation 2 to make it linear as well. We have to make the bases to be the same. We have a fraction. Let's tackle this one. So it becomes 4. Breaking it to base 2 becomes 2 exponent 2. This can also be written as great. Since the bases are now the same, we drop the bases and equate our exponents. So this one becomes equation 3. Bringing the two equations together gives us now we can now solve this one simultaneously. We have two methods. We can use the substitution method or the elimination method. Looking at our equation, I prefer we eliminate the x variable. So because the coefficient here is 1 and this one too is 1, so you can easily eliminate the x. So we are going to subtract equation 1 and 3. We bring a bracket to show that the negative here affects everything in here. If you don't bring the brackets over here, it means that your negative will affect only one variable. It won't affect all. So you bring a bracket to show that this negative is affecting everything in here. Now let's solve it together. X minus x will give us 0. It means 1 minus 1 is 0. 6y minus 1y will give us, good, 5y. Then 3 minus 2 will give us 5. The negative and the negative will give you a positive. So it becomes 3 plus 2, which is 5. We are looking for y, not 5y. So how do? We divide both sides of the equation by the coefficients of the variable. So the coefficient here is 5. Then we simplify. Therefore, we have y as 1. The moment you get of the variables known, you substitute it into any of the equations. So looking at our equation, I prefer we substitute it into equation 1. So you can say put y equals 1 into equation 1. So wherever you see y, you put 1 over there. And that is our equation 1. Good. So we simplify again. When you reach here, what do? You have to group like terms. The variable stand alone and the constant 2 goes to the other side of our equal to sign. So this becomes, you have x equals 3. This was a positive 6. So when it crosses the equal to sign, it becomes minus 6. So therefore, x is giving us negative 3. We were to find the variables and we've known it. So we can say that, therefore, x is equal to negative 3 and y is equal to 1. And that is perfect. So whenever you are given an example to solve or a question to solve, make all to be linear. In our example here, the first equation was linear. It was the second equation that we had to make it linear. So that one became, we drop it down, make the bases to be the same. Then we drop the bases down and pick up our exponent. So this became, and as we've solved together. Thank you so much. Now, let me give you a question under logarithm. Good. We have the first law of logarithm, second law of logarithm, and third law of logarithm. So in our next lesson, we are going to treat logarithm, the laws and equations involving logarithm. Thank you so much for going through the lesson with me. I believe you are going to subscribe, share and like to our video. Till we meet again, please stay safe and learn hard.